Now let's start doing some actual Metasploit work now that we've got through some of the theory. So we're going to start with MSF console. That is going to be our primary way of working with Metasploit. We'll also look at the command line interface briefly, but I spend most of my time pen testing when I'm using Metasploit using MSF console, and most of the other pen testers I talk to do the same, so we will spend most of our time in the class with MSF console. To get the latest module updates for Metasploit, you can do MSF update, and that will pull down the latest module tree and other updates for the Metasploit framework. It does update fairly regularly, so I would encourage you to keep it up to date. So I have already updated mine, so I will start with MSF console. But first we actually do want to start a couple of services. So we can start up the database. So it's service Postgres SQL and then start. And also service Metasploit start. Starts up some background processes for Metasploit and Kali. Then we can do MSF console. And it will take a minute to start. It is loading up the module tree on the fly. So if we write our own module, which we will in the exploit development section, it will be loaded as well. And it also will put up some ASCII art for us. So if yours looks a little bit different than mine, when mine actually loads, don't worry about that. There are a few different ASCII arts in there. So each time you start up, you may get something different. So let's give it a minute to start, and then we should be able to get started doing our MS08067 exploit. We're going to exploit our Windows XP system. So the only thing we need to know about it at this point is its IP address. So again, George's password is password. And if we do Windows R or Command R on the Mac, we can get a run prompt, and if we do CMD, mine's already there, so CMD, that'll open our Windows command line, do an IP config, as opposed to IF config on just about any other system you'll ever run into. We can get our IP address, so 192.168.1.76, in my case, yours may be different, of course. Alright, if I come back over here to Metasploit, sure enough, doing something else did in fact make it load. Always likes to be slow when I have the video on. So then we see our ASCII art, and again, if yours is different than mine, no worries. And we see it has, as of this recording, 1,357 exploit modules, 829 auxiliaries, 231 post modules, 340 payloads, 35 encoders, and 8 NOPs. We will certainly not see every module, but we will see examples of exploits, auxiliaries, and payloads in this section, and then we may even see some encoders. But we'll see post modules when we do post exploitation. And we're not really going to work with NOPs in this class, so we're not going to use those, but we will see examples of exploits and auxiliaries throughout the class, and as well as some posts, and certainly a lot of payloads and some encoders. When we do exploit development, those will definitely come into play, as well as maybe for avoiding antivirus, they may have some usefulness. Alright, so now we're in the MSF console prompt. So we can always say help at any point to get our basic commands. We can also say help about a specific command. So for instance, come up here, we see our core commands and some database commands. How about help and then route? That'll give us more information about the route command. So as probably expected with the word route, it is used for routing. So it routes traffic destined to a given subnet through a supplied session. So we will use that in post-exploitation. We'll do something called pivoting that will come into play, but for now we don't need that particular command. So what we want to do is find a module for our MS08067. We do have a couple of options. we can also look at the online database for Metasploit. So we go to Metasploit.com. It also has a database of Metasploit modules. If we look at, well, kind of dating my training now. If we go to exploits here on Metasploit.com, it actually sends us to Rapid7.com, so it's actually at Rapid7.com, but I always just go to Metasploit.com. We can put in our query strings. I'll just do MSO8067. And it came up with 3 results. Let's just start with this first one. Here's an exploit. And it has our exploit module. It actually has a module name up here in the URI. So it's in modules, exploit, Windows, SMB, MSO8067 Net API. Same one we saw the source code briefly in the previous video. You can also do a search inside of Metasploit. So inside of MSF console, we can say search and any string MSO8-067. And it comes up with that same exploit. So that is presumably the module we want to use if we want to exploit MSO8067. I mean, in this case, the description pretty much says it all. We may run into some instances where there may be a few modules that look like they might be the right one for a particular vulnerability, so we may have to do some more investigation. We could use the info command for that. So I can say info and then the module. So I can tab complete. So I can say exploit, Windows, SMB, MSO8-067 Net API. We can also, to name a module, drop off this first part, exploit, in the first slash if you want to. Same thing with auxiliaries, posts, etc. You can just drop off the first folder basically in the module tree and the slash that goes with it. Keep in mind if you do that though, you won't be able to tab complete, so whatever works best for you. I kind of go back and forth, as you'll see. So we can get information about a particular module. So here we go. So it gives us the name of the module, platform, of course, Windows. Is it privileged? Does it require or give system or really high level privileges? Yes, it does. It will actually give us system privileges. Metasploit license. Ranking is great. The highest ranking you can have is excellent. You have to be pretty super to get excellent. Like, you can never bring the target down, things like that. There's lots of requirements. If you look at the manuals for Metasploit at their GitHub page, you can find explanations of all of that. Great is the second one, so great is in fact pretty great. So it gives us an idea that this is a module that is pretty successful. People who wrote it, so if you write your own Metasploit module or contribute to one, then you too can be internet famous. Available targets. We'll see automatic targeting. In many cases, Metasploit can decide what the correct target is based on, say, fingerprinting the service. SMB is a good one for fingerprinting. It pretty much writes back and says, "Hi, I'm Windows XP Service Pack 3. Would you like to exploit me today?" So we have that automatic targeting, as well as several other targets. In fact, we have 67 available targets. So everything from 2000 XP all the way through Service Pack 3, Windows XP, Windows 2003, Service Pack 2 is on here, different language packs. So, of course, everything on here has had a patch release. That said, people don't necessarily patch all their systems. If you do any pen testing, this is one you may see from time to time. Exciting as a pen tester to see it, because it is, as we'll see, an easy win. It's a pretty steady vulnerability. We do have the ability to exploit it. It does give us system level privileges. That's one we really like to see if we want to break in, but it is something that can be patched. It's a quick fix, just apply the patch and it's gone. So, easy recommendation for fixing. Then we see some basic options. We'll see those again. It says our host, our port, and SMB pipe. Our port and SMB pipe have a default setting, and they are all three required. And then they have a description We see some payload information. Luckily, Metasploit will take care of all of this for us, but when we get into exploit development, these things will be of the essence. The amount of space we have for the payload, or the amount of room we have in memory in bytes. So we have 400 bytes. And it says there's 8 characters we need to avoid, so there's 8 bad characters. Bad characters will in some way break the exploit string. Again, when we get into exploit development, we'll look at that. Metasploit doesn't even tell us what those 8 characters are. Of course, we can get them in the source code if we go back to that module, but Metasploit will automatically get rid of any bad characters. Then it has the description of the flaw. Finally, some references. Again, there may be points during our pen test where there's a few different modules that look like they might be the right one. Maybe comparing our results in vulnerability analysis to these modules, like open source vulnerability database numbers. We have TechNet. Again, in this case, it's pretty simple to see which one is the right one. It's MS08067, but it may not always be named so easily. You may have to look at, say, open source vulnerability database numbers to see which is the actual vulnerability that we found during vulnerability analysis. You never know. Just maybe a hint for later. Alright, so this is indeed the module we want at this point. Again, I'm just at this point telling you this is a vulnerability that's present. We will have plenty of time to look at other vulnerabilities. All of our virtual machines have some sort of vulnerability that we can exploit. So there will be plenty of chances to find vulnerabilities on your own. But for now, let's use this module. So use, again, you can drop off exploit / if you want to. Windows, SMB, MS08067, Net API. That moves us into the context of that module, so now it says exploit and MS08067 Net API. If we do a show options, our options may be different from module to module, but all of our network-based exploits like this are going to have rhost, and it's not going to be set. That's going to be the remote host we want to send it to. We will look at some client-side exploits where we don't directly send the exploit, but this one and many of the other ones we'll look at are network-based. They are going to send a crafted exploit string over the network to another system and hopefully give us control and allow us to run our payload. So now we want to set our host to the correct value for our Windows XP machine. Again, that was over here. Of course, I've already forgotten what it was. 192.168.1.76 in my case. Easiest way to make your exploit not work is to just blindly follow me when your network is something else entirely. So be sure and set your IP address accordingly. Make sure it is the IP address of your Windows XP machine and not mine. The rhost option or your options in general are actually not case sensitive. You can do them lowercase. It is a best practice to do them in the correct case, and I will try and remember it throughout the class, but you may catch me doing it wrong at some point, and you can either use the correct case or not. Again, I would encourage you to do so. And we have R port and SMB pipe. They're both set to a default setting, 445 for R port, and SMB pipe is set to browser. The R port, in fact, that seems like it would be correct, 445. I've never seen SMB anywhere else. I suppose if you wanted to make everybody in your IT staff miserable, you could maybe recode everything, but every client probably has a hard-coded in, so I can't imagine that it would be something that anybody would ever want to do. So probably that R port is going to be correct, but if we, for some reason, needed to change an R port for a remote port, we could do the same thing. We could say set the option to set and what we wanted to set it to, but again, this one is fine how it is. We can set any option that way though, just set the option to set and what we want to set it to. Same thing with SMB pipe. For now, I'm just going to tell you that browser pipe is correct, how it is set now. We don't currently know what SMB named pipes are listening. We'll actually look at an auxiliary module that'll tell us that a bit later on for our auxiliary example. But again, for now, just go on faith that what I'm telling you is true. We also see the exploit target. It is set by default to automatic targeting. We can see all our targets again with show targets. So we show options, show targets, etc. So syntax is pretty simple for Metasploit. We can see all those targets again, but we will just leave it as automatic targeting for now. So it looks like everything is set now. If we do show options, in fact, we now have our host, so everything should be good to go. We have forgotten one thing. We have not set a payload. Metasploit will, if you don't set a payload, choose a default payload for the module and do its best to run correctly. But we should certainly know how to set a payload. The default may not always be what we want, so we should certainly at least learn how to set a payload. So what we want to do is do a show payloads. So show options to see the options, show targets to see the targets, show payloads to see the payloads. Probably catching on here. If we do a show payloads, this is going to show us only the payloads that work for this module. So we're only going to see Windows payloads here, nothing for Linux or iPhones or Androids. We'll see pretty much all of our Windows payloads, though. It does have to be able to fit in that 400 characters of space, but that's a pretty good amount of space. We should probably see pretty much everything here. And we'll learn more about the fitting in space when we do our exploit development. We see something called Meterpreter come up. That may not be familiar to you. Meterpreter is Metasploit's special payload. We will see lots of Meterpreter, particularly in our post-exploitation section. And we also see like some basic command shells. We see a reverse shell, a bind shell. We talked about that during our Linux basics section about our bind shell and reverse shell. Bind, it opens on one system and listens, and then we connect to it. Reverse, on the other hand, it actively pushes the shell back to our listener on Kali. So we did that with Netcat. Does the same thing automatically in Metasploit. So let's go ahead and set the payload to, say, Windows shell bind underscore TCP. So that will make a bind shell. You will notice if you go through that there's actually one that's Windows /shell underscore bind underscore TCP, whereas this one is Windows /shell /bind TCP. So they look like they are exactly the same. They're practically named the same. They just have extra slashes. That is a staged payload versus an inline payload. This one that we've chosen with the double slash is staged, whereas the one with only one slash is inline. An inline payload puts the entire payload in the original attack string. It does take up more space, whereas a staged payload just puts in enough commands to call back and finish the payload, basically. So we'll have it set up something called a handler. It will do that automatically, which will know what it needs to do in order to finish up the payload. So in our case, either will work. They're both on our list, but it may come into play sometimes in exploit development that we may want to do a staged payload. But again, either will work here, but we chose the staged one, and it is bind underscore TCP. You can do anything that's on this list. I do encourage you to spend some time playing around with payloads at the end of this module before we move on. Maybe try out Meterpreter. But for now, let's do a show options again. We see our old options like rhost, rport, SMB pipe, but now we also see some payload options that have been tacked on. So we have exit function, as the name implies, that's how it's going to exit. So we have SEH for the structured exception handler. We'll talk about that when we get to exploit development, but that's how Windows deals with exceptions. So when something goes wrong. Also has thread, which is the default, so it'll just kill the thread and also kill the process or do no exit function at all. Thread is a good one. Just exit the thread and continue on. Hopefully it won't bring the server down. Lport is going to be our local port that it's going to open that bind shell on. So 4444 is the default. You can change that same way. So we could do set Lport to 1234 for instance, but that's not strictly required. Of course, some intrusion detection systems, if your client has them, may just automatically block everything on 4444. Oh, your Metasploit, go away kind of thing. I mean, they are all signature based, so easy to get around that by just changing the port. So, of course, in our lab, we don't need that. We don't have snort or anything listening at this point. And it also has rhost as well. Not required, but that's the target address. We've already set that in the previous section when we did rhost up here. So that's already set for us. So that's all we need here. Our options again will be based on this particular payload. If we had done a reverse shell, for example, it would have asked us for the IP address to call back to. Since we did a bind shell, we don't need that here. But it's going to be different every time based on what you choose for your module and your payload. Some of them may be the same, but there will be variants. And so you can always do a show options to see what you need. So now we should be really good to go. So we can say exploit to tell it to run. So just type exploit. And if we have indeed set everything up correctly, we should be good to go. And sure enough, we now have a Windows command prompt. We are at C Windows System 32. This does exploit the SMB server, which is a system service. So first thing we did was open up a bind handler. So we chose a bind payload, so it automatically sets up a handler to deal with it and connect back and finish the payload. Since it's staged, it automatically detects the target. We did tell it to automatically detect the target, so sure enough it does. Figures out it's Windows XP Service Pack 3 English, selects the correct target, and then it does send over the attack string. It does encode it. I said we would kind of see encoders here. This is one of the encoders from Metasploit x86 Shikata. That's Japanese for it can't be helped. As we'll see in our avoiding antivirus phase, it actually can be helped. Antivirus will in fact pick up Shikata, but we will look at other ways of getting around antivirus. Primarily, encoding is really just to avoid our bad characters. We saw there were 8 of them that needed to be avoided here, so it will encode itself to get rid of any bad characters, and then it will prepend a decoder basically at the top. So first thing it will do is decode itself back into its original form, and then our payload will run. And then we send over our stage, and the handler deals with finishing it, and then we get our session. Metasploit considers communication between our target and, in this case, Kali, to be a session. So this is session 1, and now we have, again, our command prompt, so we can run Windows commands that we are interested in. And when we're done with it, we can close it with a Control-C that will abort the session, but we have another option. We can background the session with Control-Z. So it'll ask us, do we want to background it? If we say yes, it will keep the session open, but then return us to the Metasploit prompt. And then if we do a sessions-L for list, we can see all of our open sessions. Currently we only have 1. If we want to interact with the session that's in the background, we can say sessions-I, and then the session number, and that'll drop us back into the session. So we can move from Metasploit out of sessions and back into them. We don't necessarily have to be done with them before we put them in the background. We can always bring them back as long as there's still network communication between the two systems.